Today I'm gonna make a real, legitimate rocket stove. That's not a rocket stove. Using this steel tube. You're an idiot. Your video is too long. If you've made any kind of rocket stoves, or do you know what you're doing? If you've done any videos here on YouTube, you'll know that there are plenty of people out there that are gonna tell you that you're wrong. Whatever. And when it comes to rocket stoves, there is a very specific set of design parameters. I took a lot of time to write this comment. That makes a true 100% verified rocket stove. No, I've never made a video. There's also a whole lot of rocket stoves here on YouTube, where certain principles are used, but not all of them. I'd rather just complain about your video. And from my perspective, that's okay. I think if we have airflow, if we have elevated fuel, if we have a chimney or riser, those are the important components. When we get into the 1-to-3 ratio of firebox to fire channel to riser, that's where we get into the specific rules of a rocket stove. And that's what I'm going to build today. Well, no, I haven't ever made one myself. Just read about it. In spite of the trolls that show up in the comments from time to time, there are a whole lot more of you who have great suggestions, ideas, and encouragement. And even constructive criticism. And I appreciate that as well. But if you're mean, you're just gonna get banned. Hey, beat it. Whatever. On with the video. So here's a look at the metal that I'm working with today. I've got some box steel and a few salvaged parts, as well as some assorted bar. The metal bucket is going to be used to make this rocket stove into a biochar retort burner. I'll explain a little bit more about what that means when we get to that portion of the build. For the body of the rocket stove, I'm going to be using this 4-inch square tube hot rolled steel. There are different gauges, but that's not going to matter for the purposes of this stove. I picked them up in the drop room at my local metal supermarket, so I was limited on choice. The ratio I'm going to be using is a 1-to-3 ratio. 1 for firebox, 2 for fire channel, and 3 for the riser. So I'm going to put on my favorite getup and get to grinding. So I cut this piece like this with a flap so it will connect like this. Although I need to shorten the tab side just a little bit so that it fits up correctly. Alright, I'm going to switch to a grinding wheel, clean up all the joints, and then I'll weld it up. When I cut the square tube, the side actually bent a little bit. I think just relieving the pressure. I'm going to weld the top section in first, and then clamp that bent portion to weld it in place. A quick disclaimer here. When it comes to welding, I am still a novice. But a project like this has very simple welds and it gives me a great opportunity to practice. I'm really enjoying what I've been able to learn so far, but I've got a long way to go. So welders out there, please leave me some feedback in the comments. Tell me what I'm doing right, but tell me ways that you see that I can improve. And if you're new to welding, it's not as complicated as it looks. It's important to have the proper equipment. You can pick up a welder on Amazon for like 200 bucks, some gloves, a jacket, and a helmet, and get started. Adding basic welding to my skills has opened up the door to many, many more projects that I can attempt. So if you're at all curious about welding, give it a try. I'll put links to the basic gear that I've got in the description below. I'm gonna tack it on all sides and then come back and put down some beads. Now I'm going to tack it in place and try not to melt the rubber gaskets on my clamps. It's a little messy, but that's sort of part of working with a MIG welder, the spatter, especially with flux core. The nice thing about welding though is you can always grind it and make it look good. So I'm gonna go ahead and grind these welds here before I add the riser, which is gonna make this thing a lot heavier. Now I'm gonna weld on the riser. Clean it up. Alright, so the body of the rocket stove is finished. We've got our 1-2-3 ratio, and it would function as a rocket stove just like this. But one more element of rocket stove design that I want to add is secondary air. And that is where we're going to route air in underneath and then up to a point somewhere in the middle here of the riser. We're going to route it underneath the fire tunnel in order to preheat it. So to do that, I'm actually going to add a pretty heavy base to this out of some C-channel steel, a piece of scrap that I've got. Then I'm going to pull a tube off the end of that and insert it into the middle of the riser. One rocket stove channel in particular that I really enjoy watching is Little Aussie Rockets, and he just built an amazing vortexing rocket stove that you might want to take a look at as well. I'll put a link to it in the description below. With the length of the fire tunnel being 16 inches, I want 16 inches of this, which conveniently is exactly what I have between the end and this post that I cut off here in the middle. Let me cut this off. Now I'm going to line up the rocket stove body on the base and then mark where I need to clean it up for the weld. If you're wondering about why this is open here, it's because I'm going to weld it onto this. I'm going to put a solid bead in down near the riser, which has the open end, so I'll want to seal that from any air leakage. Then I'll put some shorter beads to attach the rest of the J-tube to the base. The way this is going to work is that my secondary air is going to come in underneath here, be warmed by the bottom of the firebox and the fire tunnel. And then we're going to close off this end partially and bring a tube up here on the back of the riser. Put a hole in here and allow the air to enter at this point. I'm going to close this flap down and weld it closed. That's close enough for welding. I'm going to position the secondary air tube so the holes align and then weld it down. And now I'm going to fit up some plate to cover the back of the air channel here so that the air can only enter from the front. Well, if this isn't a J-tube rocket stove, I'm not sure what is. This is the beast. I've got a little more grinding to do, and I'm going to put a front plate on this with a hole in it to restrict the airflow underneath. But I'm really dying to test this out. I think what I'm going to do is make the retort biochar creator a second video where I modify this, because the reality is you could stop right here and you've got a rocket stove. Some pot standoffs on the top, something to let the air flow out underneath your pot, and then some dampening for this front area here is all it's going to need, and a coat of paint to be a legitimate rocket stove. But I want to test this thing out. Too much welding, too much grinding, not enough burning. Let's take this outside and give it a test. My cousin Rob picked me up a bellows. See if we can use this to get the draft going. The fire's going and it's burning in the right direction. Flames out the top, almost. Steel is bluing. The train's here. Perfect. Alright, so I'm pretty excited about the performance of this stove. You know, a true rocket stove, there shouldn't be any flames coming out the top. But it's got a really nice sideways burn. I'm excited able to burn this split up lumber. I've got a ton of that I've saved, and I wanted to use it for fuel. So not only will I be using it to make the biochar, but I'm also going to use it for the fuel to fire the rocket stove. Stay tuned for part 2, where I add the components to make this into a retort biochar maker. And of course we'll paint it up and add the dampening system, a few more refinements to make this a legitimate rocket stove, including some pot standoffs, because when you're making biochar you can also use the heat for cooking. Special thanks to my patrons for helping make these videos possible. If you think I've earned it, consider joining me over on Patreon for extra perks and community. As always, our mission here at GreenShortz is to help you see green so you can be green. And save a little green by doing it yourself. Thanks so much for watching. Please like and share, keep all the great comments coming, and we'll see you in the next video.